always dependable.
Protein purification is a recognized method of sample preparation. A common manual method involves several independent steps. The organics and proteins are added in measured amounts and then mixed by vortexing. The resultant mixture is centrifuged for separation. The organic is aspirated and transferred to the destination plate. Tomtex Quadra 3 can provide walk-away automation for this complex protocol. Filtration is used in lieu of centrifugation for sample separation. The choice of filter plates can provide a cleaner sample for analyzing the end result. The Quadra 3 is provided with an automated vacuum box. The incoming filter plates, capture plates, and sample plates in-feed and out-feed under automated program control. During the vacuum portion of the cycle, the pipetter tips are washed ultrasonically. The protocol depicted is generic. The volumes and organics are modified for each specific case. For brevity in this presentation, some steps are shown in fast time. The first sequence loads a mid-sized microplate into the vacuum box as the capture plate. Next, the filter plate in-feeds from the stacker and is placed on top of the vacuum box. Prior to aspirating the organic, the tip headspace is filled with organic vapors by aspirating and dispensing 450 microliters once or twice. Following this, 400 microliters of the organic may be aspirated accurately without dripping. The organic is then dispensed to the filter plate, which is not under vacuum at this time. Following the dispense, a time dispense is made to blow pressurized air through the tips. This is followed with another time dispense prior to aspirating the aqueous sample. This is to clear the organic vapors. Otherwise, an accurate volume transfer of the aqueous sample cannot be made. The aqueous sample is added to the organic previously dispensed in the vacuum box. The last 20% of this sample is injected with air pressure to assist in mixing. The next sequence is mixing the organic and protein sample prior to vacuum filtration. 450 microliters of air is aspirated in free air and then dispensed into the mixture just above the filter bed, using bubbling to create an effective mixing action. Prior to aspirating the next 450 microliters of air, a time dispense is made to clear the tip orifice of any congealed protein. This bubbling action is repeated 3 to 6 times. The total number is determined empirically. After the mixing function, the program applies a regulated vacuum from the mini-trap. Concurrently, the inner capture plate is lifted to be in contact with the filter plate tips. The vacuum time is determined empirically for the application. During this vacuum time, the Quadra tips are washed ultrasonically. They aspirate fresh water from the bottom of the wash station and dispense it above the station. The effluent is washed over the top of the wash station to waste. A carryover test was made using 4 different compounds at 4 different concentrations. The results were measured with a micromass mass spectrometer. There was no detectable carryover measured. This confirmed similar testing using other detection methods. If there was carryover, it was below the detection level of the measuring instrument. After the vacuum period has elapsed, the program turns off the vacuum. The robotic hand retrieves the filter plate. It is placed in the right front stacker. The capture plate is retrieved and placed in the left front stacker with the original mating sample plate. At the conclusion of this process, the entire sequence can repeat automatically for the next sample plate. The total time per sample is primarily determined by the vacuum time required. The Quadra machine time is 5 minutes, not including the time allowed for bubbling action for mixing. This is application dependent. The entire program may run unattended and repeatedly from sample to sample in a precisely controlled manner. We thank you for your time and interest in our products.